Hi, and welcome to this Daylight Visualizer tutorial. In this video, I'm going to show you how to make a daylight analysis using Velux Daylight Visualizer and SketchUp. This will be a two-part series. In the first part, we will show you how to model a simple house, and in the second part, we will analyze the house in Velux Daylight Visualizer. Let us open up SketchUp and choose the architecture template for the project. Under Window, clicking Model Info, we can check the precision of the model. In this case, 0.0 centimeters is just fine. If we were to, let's say, do interior modeling, we would have to increase this precision to accommodate for the smaller dimensions. The next step for us will be to look at the materials. We can see that there's already some materials loaded into the project. These are used by the loaded-in model right here. Since we don't need the materials, we can go ahead and delete them by either doing it manually, by right-clicking and clicking Delete, or we can go up under Window, Model Info, Statistics, and clicking Purge Unused. This will automatically delete all materials we aren't using in the project. Let's now create our own materials to use in the project. With the newest version of Daylight Visualizer, we can create and assign materials in SketchUp and export them directly into Daylight Visualizer. When opening Daylight Visualizer later, the materials and their properties will already be assigned to the objects, which leaves us with less work and a cleaner workflow in Daylight Visualizer. Clicking Create Material, we can make our first, the ceiling material. We're picking HSL, which stands for Hue, Saturation, and Lightness. For the ceiling, the lightness will be 90, which correlates to a reflectance of 0.9. Pause the video and create the following 10 materials. Now it's time to import our CAD drawings. These drawings will help us model our house once positioned correctly. A good habit is to always check the scaling of the drawings. Here we can check the door frame, 88 centimeters, along with the wall, 21 centimeters, and see that both measurements are reasonable. Seeing that the drawings are all in the same group, we can go ahead and make new groups for the individual drawing. We do this by simply right-clicking and choosing Make Group. We can also delete the original group by right-clicking and choosing Explode. Next up would be to position the plans correctly, so we can use them accordingly to create our house. Selecting the ground floor, using the Move tool, we can put it into position and define the bottom of our future model. We also need to rotate all the elevation drawings. To do this, we can create a temporary box that will help us. Using the rotation tool, the elevation drawing can be oriented correctly. Let's also delete the box again. We can identify the front of the house by this entrance. So by looking at the elevation plans, this one is the correct one for this side of the house. Using the Move tool again, we can move the plan into position by aligning the outermost wall with the ground plan. Here, we can choose the correct elevation by looking at the window placement and size. Once again, we rotate the plan, as well as align the outermost wall with the ground plan. With all 4 elevations in place, we only need to position this section that goes right through the house. Here, we'll place it right over the stairs so it all lines up. And the very last, the attic door. With our plans in place, we can now proceed to the modelling phase of the build. Choosing the rectangular tool, we can begin modelling the exterior walls by starting with this corner, extruding up to the first level. Having selected the Extrude tool, hold down the Control key and extrude the wall to the window opening. Another trick is to select the Move tool, holding Control again and duplicating the face over. From here, we can easily extrude the rest of the walls while making sure the faces are facing the correct way. Working in groups is always easier, so let's select all walls by left-clicking 3 times and making one big group. Next up will be to model the window openings. By selecting all these lines, we can hold down Control and duplicate the lines down to the upper part of the window, then proceeding by extruding the wall out. Doing the exact same, we can create the lower part as well. With the outer walls in place, we can continue by modelling the floor as shown here. Remember to make it a group and move up the ground plane to floor height. Let's hide this attic plan for the time being and go on with modelling the interior walls. Make a group for the interior walls and model inside this group, just as I'm doing here. With the interior walls finished, we can create the door openings the exact same way we created the window openings. Move holding Control and duplicating. Let's model the doors next. Daylight Visualizer doesn't need the doors to be detailed, so we will just model a simple plane of a thickness of 1 centimeter. In this tutorial, we are assigning all the materials at the end, but you are of course free to assign materials whenever you want. A little detail we need to fix is the bottom of the windows. Here we will extrude the door out to match the edge of the window. Now it's time for the windows. Windows, just like the doors, can be modelled as very simple objects, since we don't need unnecessary detail for the analysis. Using the rectangle tool, we can close the window openings and create a base for the window model. We also need to know the thickness of the window frame. In this case, it looks to be 12 centimeters. Then we can go and use the Offset tool to model the window frame. Clicking on the plane, typing 12, and hitting Enter. Having the tool still selected, you can repeat the Offset command by simply left-clicking on the other window panes. No need to touch the door, since we will model it without glass. In this instance, we must create an extra panel for these two windows. Do this by selecting and duplicate this line, aligning it with the elevation drawing. Now we can select all the future window panes and click Ctrl+X to cut them. With the panes cut out, we can extrude the window frames into position according to the ground plan. In some instances, you may need to hide the existing exterior walls, as I'm doing here. To get the walls back, simply go to Edit, Unhide, and click All. I will, however, hide the attic floor plan again. Since we cut the window panes out earlier, we have them stored in our clip box. To get them back, we go to Edit and click Paste in Place. They are already selected, so we can easily make a separate group for them. Lastly, we just need to move them into the middle of our window frames. It is very important at this moment that we don't have any gaps between the glass and the window frame, or between the window frame and the walls. Using the elevation drawing and ground plan, we can create the external stairs. Creating the interior stairway, we start by modelling just a single step. Then we make a group and duplicate the single step. Another way to achieve the same result would be to copy the step and typing in X10 if you want 10 extra copies of the same object. Now, using the Scale tool, we can scale up all the steps to their desired height. select All, and make a group. Going into the group, we can press Ctrl+A, right-click, and select Explode. To finish up the stairway modelling, we will also model a room beneath the stairs. Draw a vertical line in this corner and hide the interior walls. Finish up the room by drawing a line perpendicular to the stairs and extrude out the room. With the ground floor all done, we can move on to the first floor. Go ahead and draw a rectangle, just like we did with the ground floor. Extrude the floor out to the corners. Next up, we need to cut a hole for the stairway so it can be used. Lastly, cut the stairway right at this line so it matches up with the drawings. Now it's time for the walls. Double-click the walls to enter the correct group. Then we'll make a new object by copying this face, Ctrl+C, and then clicking Paste in place. Just like before, we can extrude up to create a wall. The specific height will be addressed later. Looking at the elevation drawing, we notice a tiny little overhang we need to model as well. Simply do this by extruding both sides of the corner out to match the elevation drawing. Remembering to work in the correct group, we can start modelling the bottom of the window openings. As shown before, we duplicate the line by hitting Ctrl and keeping it vertical by holding Shift. Then simply extrude. Another recommendation would be to always check for small mistakes in the CAD drawing. One way to do this is to check the midpoint of the model with the midpoint of the CAD drawing. SketchUp will automatically show us the midpoint of the model. So click the point, and while holding down Shift, we can restrict the line to only move in one direction. Then we can hover over this point to check whether everything is lined up or not. In this case, we are off by 0.2 centimeters, which is acceptable for our simple model. Jumping into the Walls group, we can set the correct height for the outermost walls. And following the elevation drawing, let's model the slope of the roof into the walls. Simply create a contemporary line from this corner up to the midpoint and cut by using the Extrude tool. Continue the line all the way down by holding down Shift and cut out the rest of the wall. Four more windows need to be modelled, so let's remember to create the group at the very beginning for a better workflow. Going into the group, you can model the windows just like we did beforehand by following the CAD drawings. Again, we see a panel that needs to be modelled. As you may remember, we do this by duplicating this line and aligning it with the drawing. Using the same workflow as before, we select all the window panes and cutting them by using Ctrl+X. For easier access, we'll hide this wall group so we can see what we are doing. Then, simply extrude the window frames according to the drawing. To get the window panes back, we exit the group, clicking Paste in place, and while they are already selected, we can make a new group for the window panes. Then, simply move the panes to the middle of the frame. With the windows done, let's unhide the walls again. Next up is the ceiling and the interior walls. Following the section drawing, we can model the ceiling by starting with a rectangle, then extruding it out to all sides and cutting out the pieces we don't want, as shown here. For the interior walls, we'll follow the drawing plans just like we did on the ground floor, remembering to create and model inside a group. We also need the interior walls to line up with the slope of the roof. One way to do this would be to select these lines, copy them, enter the interior walls group, and click Paste in place. Then we can move the line over and use it as a temporary cutting tool. To create the door openings, we select these lines and duplicate them up to their desired height. We'll finish up by also creating the doors. Giving them a thickness of 1 centimeter and grouping them all together. To finish modelling the first floor, we just need to model this little wall to enclose the stairway. Using the ground plan and the section plan, we can go to the next step and model the roof. Here we will only model one side of the roof, since the roof and the window placement is symmetrical over the center ridge of the house. Go ahead and move this section over for easier modeling. We'll draw out the outline of the roof, following the section plan, just as I'm doing here. Now it's time for the roof windows. To create an accurate roof window, let's go to the website called bimobject.com to download a roof window model we can use as a reference. Type in Velux and click over here to change the type to only see SketchUp window models. We will choose this top-operated window, so let's click and download it directly for SketchUp. Opening the window model, we see a lot of detail we don't need for this project. So, using this model as a reference, we can make our own with only the details we need in order to analyze the house in Daylight Visualizer. Starting out, let's just create a simple plane using the model itself. Then move it over so we can work on it independently. Measuring the thickness of the frame, we gather a thickness of 3.5 centimeters. We can then use this, along with the offset tool, to create the frame. Delete the middle and extrude down to the bottom of the frame using the model as a reference. Next up, we select these 4 lines and duplicate them down to this height. To get the right dimension, we must measure again, this time the whole frame. Which measures to be 8.9 centimeters. We can also check to other sides to see if they are also 8.9 centimeters. This one is. This one is as well. This side, however, measures 10.4 centimeters. To help us, we can create some additional lines to extrude to the correct distance. With the frame in place, we can move on and create a pane for the glass. Remembering to put it into a group. We can also copy the handlebar over, even though it won't have a big impact on the daylight analysis. And that's our roof window all done. To import it into our house model, you can copy it, Ctrl+C, switch window and paste it, Ctrl+V. It gets placed somewhere in the model, so we need to place it into position. However, firstly, we need to check the size of the window in the CAD drawings. Here, it measures 94 centimeters on this side. If we take that measurement over to our window, we can create a few temporary lines. It's important that we do not scale the window with the built-in scaling tool, since this would result in scaled-up window frames, which we don't want. So, we need to go into the group, select these parts, and extend them out to match. Let's check the length of the window. (118 centimeters). Another point I would like to make is that you can always check if there's a roof window with these exact dimensions by simply going to this website and checking if the dimensions exist. 94 by 118 centimeters is indeed an actual roof window size. Let's go ahead and scale up the window in the exact same way as before and grouping together. To align the window, we use the Move tool along with the Rotation tool to put it into position. Then we can refer to our CAD drawing and line it up correctly. From here, we can draw the outline of where the window openings will be and extrude into the wall to cut. Simply extrude all the way to the back to where the first window opening starts. Then we can duplicate the face over and create all the individual pieces of roof between the window openings. With the window openings in place, we can extrude out the roof all the way while fixing some small mishaps along the way. And now we can place the windows accordingly using the Move tool while holding down Control. And don't worry about the gap, we'll fix it in a bit. Since we don't need the elevation plans, we can go ahead and delete them, along with these lines. Now, hide this face so we can get better access to the window modelling and tidy up the window openings. All tidied up, we can extrude the top of the roof a little further up. As you can see, it all looks good. We only need to extend these middle beams a bit in this direction and cut off a bit from the inside. Then we just finish up the last small details. The roof is now all done, and we can put the roof into its own group. Here we also need to make a group inside this group, specifically for the top part of the roof. Luckily, as mentioned before, the roof windows are placed symmetrically along the ridgeline. This means that we can mirror over this side of the roof and end up with a complete roof. Just make a duplicate. Right-click and flip along the green direction. And that's it for the house modelling. The house is fully modelled with all its components in place, and now we are ready to model the terrain around the house. To model the terrain around the house, we will start by making 4 circles, all with a radius of 15 meters in each of the 4 corners of the house. Group it together and duplicate to the side to find the midpoint. Then we can make one bigger circle, which will act as our obstruction. Go ahead and extrude this circle up to the top of the house and delete the top face. Group it together and move it over. I will reverse the faces. The last thing we need to model are the so-called zones. These will aid the analyzation of the model when we get into the Daylight Visualizer. You can interpret these zones as small work planes that can give us great insight into the specific lighting condition at predefined locations we choose. To model them efficiently, we can create a section in SketchUp by clicking right here, choosing a flat spot and displaying our cross-section by clicking right here. Using the Move tool, we can drag the section a little bit down. Now that we can see what we are doing, we can begin creating the zones. Start by drawing out each room, either with the Rectangle tool or just the Line tool. For this bigger room, we can divide it into 2 zones, one for the kitchen dining room and another one for the living room. To create the zones, we first need to make a 50cm offset away from the walls. This 50cm gap will ensure a more precise daylight calculation. Then, selecting all the zones, we can copy them, Ctrl+C, delete all the planes, and then clicking Paste in Place. We will then end up with all our zones, one in each room. Lastly, before applying material, the zones need to be moved up by 85 centimeters, which is considered to be the standard work plane height. The zones each need to be assigned to a separate material in order to ensure a smooth import into Daylight Visualizer. Creating a new material, the most important part will be the name of the material. Here we will name the zones, starting with W zone, which tells Daylight Visualizer that this material should be considered a zone. Then we can go ahead and do the same for the remaining zones, naming them accordingly. Moving to the first floor, additional zones will have to be created. In this case, a 20cm offset would be more suitable. And again, select all the work planes, Ctrl+C, delete the planes, and finally move up 85 centimeters. Then we need to create 5 more materials. All that's left to do in SketchUp is to apply the materials to our model. Starting with the obstruction, we simply click the terrain and choose the correct material we made in the beginning. When the material is applied, we can hide the group for better visibility and move on to the next element of the model. You can do this for the rest of the elements as well. The ceiling and the floor of the first floor need separate materials, so we must create another group inside this one. Simply enter the group, select the upper plane, right-click, make group, Ctrl+X, and paste in place. This allows us to give a separate material to each element. To assign materials to the windows, we will select them all, explode them to split up each window, then select all the window panes and group them together. Lastly, we can group the window frames together and assign the correct material. Unhiding everything shows us the complete house with all materials assigned. To make sure Daylight Visualizer only imports the materials the model is using, we can use the same trick we learned in the beginning. Window, Model Info, Statistics, and click Purge Unused. We will also double-check the polyurethane material is not being used, so we can delete that one manually. The SketchUp model is all done, which means we can start the daylight analysis using Velux Daylight Visualizer. Simply save the model as a SketchUp version 8 model and with a more recognizable name. Thank you for following along, and see you in Velux Daylight Visualizer.